Okay, hi everybody. Um, let me just a second. Okay, I'm gonna talk today about Jetpack Compose, and it's like a completely new way to build an Android UI. A little about me. I'm Vlad Pylyp, and I work at Volpis. Android developer at Volpis. I've developed about 10 projects, and some of them have like 1.5 million of downloads right now on the Google Play. Okay, go next. So our agenda for today is talk a little about what do we have in building Android UI today. Then we'll talk about declarative UI and declarative programming versus imperative programming. Then we can start talking about Jetpack Compose and see some examples and summarize everything. How do we build UI today, and what is the problem with it? Today, actually saying today, I mean today and the last 10 years, because almost nothing has changed since 2008. And compared to the time that Android OS was created, user expectation is really grown right now, because that time we could create our UI like using just liner layout, button and edit text, and that was enough. But today we have like much different devices. We have like larger devices. We have like big touchable screen, and users want some motions, some animations, user want to see beautiful things, beautiful design, and that's all we build today using same technologies they used 10 years ago. It's not like so easy, and it requires us to write a lot of boilerplate code. How do we build an UI today? We're still using same XML or programming views using Kotlin or Java. And we have this view.java class. Is there anybody who saw the code of Vue.java? No? Nobody? Okay, and what is the problem with this class? How do you think? Sorry? Yeah, you're right. It's like 30,000 lines of code, and it's really bad, because it's like some God object that do all the stuff, and all the views we have like extends Vue.java and overrides just maybe 100 line of code and a few methods. So it's really not good, because we really don't need all these methods. We really don't need all this stuff. But we take it to each view we create, and it's not good. Okay. How do you think? What is the most painful for you to create Android UI today? Okay, something else? Okay. Yeah, I got you. You're right. You're right, really. And I actually have my list of these painful things. You can see it right here. And my list includes next thing. It's boilerplate. Maybe you would say I don't have boilerplate in my code, but just remember your recycler view adapter, for example. And what you have to do to implement recycler view adapter. You have to override on create view holder, you have to override on bind view holder, you have to override get item type, then you have to create view holder, you have to create XML for this view holder, then you realize that you need few more view types, then you have to override get view type, then you have to create few more view holders, then you have to create few more XML for these view holders. And it's all a lot of code, really. Some point of time, you'll realize that your onCreate view holder will look like this one, and your get view type will look like this one, and it's really not so good. Yeah. And then you see that your adapter is like 268 line of code, and it actually not so much, but what if you could create the same thing just in 200 or 100 line of code? So boilerplate. The second thing is that Android UI toolkit is hardly bundled with Android framework today. And what's the problem with this? For example, we don't really get some toolkit updates often or some bug fixes from Google, because we actually need to update like Android version or actually Android itself. And yeah, they kind of have a solution. It's support libraries, but they also can't change everything in these libraries, because they also depend on Android framework. So next problem is screen rotation. I think that I don't have to talk anything about it. Everybody knows this painful thing. Then inconsistency. What is inconsistency? It's like you have to create XML and you have to code in Java, and you really can't like create your UI using only XML or only Java. I mean Kotlin, and you have to synchronize them. You have to your views have some local states, and you have to synchronize them with your data. So it's really painful thing. And styling, as we mentioned, styling is also not so good, because yeah, you like write these styles in XML, but I don't know. For me, it's not really like comfortable to do it, because, for example, you extend some theme, for example, material theme or app compat theme, and then you'll find out in some point of time or that you'll find some padding on your UI that you didn't expect to be there, and you're finding in this 3,000 line of code what to override to get rid of this padding, and then you need to change your theme in runtime, and that's really hard to do and looks not pretty well. So declarative. Can it help us? Can declarative way to solve our problems? Actually, yes. Actually, yes, it can. How? We'll talk about it a little later today. But now let's talk about what is declarative versus imperative. As some guy from internet says that declarative UI means you describe in some kind of language what do you want to achieve, and you don't have to like say how to do it. You have to just say what you want to in result. Let me just a second. Okay, how does declarative look like? Is there anybody who's worked with Lisp or similar languages? Yeah, you're cool. You like the joke. So it's declarative, you know? No, I thought it would be funny. Yeah, let's go next. Okay, it's a good example to understand the difference between declarative and imperative way to programming. Can you see the code? Okay, so we have this method find in list, and in imperative way we tell in the program how to find the item in this list. We need to iterate through the list and check on each object if it contains our search and query. Then we return this object. We just say how to find something in list. But how would it look like in declarative way? In declarative way, we just say find and what? And that's all. We don't really care how it works under the hood. We don't need it. We just say what we want to achieve. I have one more question. What other languages do you know that works like that, declarative? I mean, okay. I mean, useful one. Useful one for even in Android, and we use it really often. Okay. Yeah, but by the way, Kotlin is also declarative, can be. But I mean SQL, it does the same thing. Like you say what you want to get from your database, and it's like, and you doesn't care how it works. Okay, now when we know the difference between declarative and imperative, and we know what is imperative, we can we can actually find out that our UI is imperative right now. Yeah, but let's see how would declarative UI looks like. What is declarative UI? Declarative UI is function of a state. Actually, we'll back to this formula a little later, and now let's see how it looks in code. We can see the same example as on the previous slide. It's imperative, it's declarative. What's the difference? We just call the function that button and set it some state. So, Jetpack compose. Now we are ready for it. Just a second. One of the missions of Jetpack compose is to reduce the amount of code and to increase the speed of development. And what is Jetpack compose? Jetpack compose, it's totally unbundled UI toolkit from Android framework. It doesn't depend on it at all. I mean, you can just include it like any other library, like Retrofit or something. It's a part of Android X now, and you can just include it into your project and try, but don't do it. I will tell why. I will tell why a little later. It's inspired by web development frameworks like React, Vue.js, and also really similar to Flutter. And why did we just talk about declarative? Because it's fully declarative. It's like you don't have a choice. Okay, composition over inheritance. Many developers say that you should use composition over inheritance because inheritance is like bad in most of cases, and they're right. But Jetpack Compose also will not allow you to use inheritance at all because it's functions and you can extend functions. So it's really cool because you don't extend anything and you just create some small pieces and you can build some biggest view from these pieces, and it's like reusable. And sure, Kotlin. It's only Kotlin. Jetpack Compose works with special Kotlin compiler plugin, so we can use it only in Kotlin. But who develop for Android in Java today? Oh. I'm sorry. Okay. But there is also but. And Jetpack Compose is pre-alpha right now. And that's why you shouldn't use it at all. I mean, in production, you don't have to. You shouldn't use it. You can try it some your like pet project, but don't use it in production because it's pre-alpha, and you see this screen and think, okay, it's release, yeah, and you will think that this is pre-alpha, yeah? But you're wrong. This is pre-alpha. So why you shouldn't use Compose right now? Because it's changing. It's changing right now, and Google can remove or add some new methods tomorrow, today, and all your project will be broken, and you would have to rewrite everything. So, what are UIs? A little more talk before we get to Compose itself. Okay, what are UIs? UIs are actually trees. Not that. That trees. And somebody would be surprised, and somebody would say, why are you telling this to us? It's obvious, everybody knows it. But actually, it's the thing that we should understand before working with composes, because actually, even in current Android development UI toolkit, UIs are trees, but it's like hidden from us under the objects, under the API, and we don't communicate directly with these trees. We have like this find view by ID method, and as long as we have it, we use it, and we don't really care how does it find this view. Does it is it doing some view traversal or tree traversal or something? We don't really care. But it doesn't work like that with composes. Okay, let's back to this formula. I'll try to explain what actually, why is that like that. You see, we have this UI on the left side of equals of our. So we have on the left side, and thank you. And this is a function of state. So if state changes, our UI changes. If function changes, our UI changes. But if UI changes, it will not have any effect on function or state. Is it clear? Yeah. I can try explain one more time. Okay. Okay. For example, if you're using something like MVVM, you know there is a state, and your state is like your data source, your single source of truth. It's your database or your API, backend, or something like that. And you have like UI, you have some custom views, you have some fragments or something, and usually your UI have its own state, like we have text view and it has text, or we have some list and we have recycler view adapter, and this adapter has his own list of items, and you have to synchronize them with your backend. But when your data changes from database or from backend, you have to update your UI. And here the problems start, because we need to keep the view and your data synchronized. You know. Let's look at this example app, and what happens if I click remove button? It's green button on the right. What happens if I click remove button? What should I do as developer? Should I remove this item from recycler view adapter and then make API call and then wait for response, and then if response fail, should I return this item, or when I click on remove button, should I do like API call first and then wait for response and then do actions after response? Actually, both of cases are acceptable, but in both of cases we have to synchronize our states. We have to synchronize recycler view state, and we have to synchronize it with our data. So what if we can model the UI as function that takes a state? This function. And okay, let's see this code. What will it print? Kotlin unit. So it returns, I would say, nothing. And you can, it has no state. You can get any state from this function. It like say tell you, hey bro, I have no state. I can't give you nothing, anything. Sorry. And examples. Okay. It's a Klug Compose example app I wrote 2 days ago, or maybe nights, I don't remember. What does it do? It's like a master detail flow, just list of users. You can remove it, or you can see detailed data about this user. We have like a view model with few methods and users list. And we have single activity. It's actually all the code in this activity. We just override on create method. And what is interesting for us here is set content method. Set content method is like entry point to composes. Because actually annotation compose is not like annotation. It's more like a modifier. For example, suspend in coroutines, and we can call compose function only from compose function, but we need some first function where we would call our compose function. So what happens here? Our material team and our app is also compose functions, but we'll back to them a little later. Let's see implementation of our view model. We have users list here, and you can notice that this list is of type model list. What is model list? I will try to explain using this simple example. We can see here clock audience data class that annotated as model. What does this annotation do? It actually says this data class to be observing its mutable properties, because we can see here one immutable property and one mutable property, and actually one more immutable property. So registered, it represents the count of all registered users to today's event, and present represents the count of users that actually came here. Okay, and attendance percent represent the percentage of members here. What happens if our present changes? For example, we add one more member. As this class observe its changes, once the present change, it will tell it will like tell our compose function to recompose, to redraw, you know, and only the function that depends on this state, on this object, will be recomposed. So, for example, if we have like a list of users, and we'll change one user at the middle of this list, it will redraw only this user on the UI. It will not touch any other users. It's something similar to diff utils, but it's more complex, and it works a different way under the hood. And actually, I didn't add this to current presentation. I mean, how does it work under the hood, because it would take 1 more hour. But we can actually prepare another presentation for next time. So. Is it understandable? How does it work? Okay, good night. So we just like we are done with our state from our function of state. It's actually state. And now let's go to function itself. Function here you can see the function that draws our button, and it just like bunch of functions that you call one inside other one. So we here we can see this padding here. It's also function, and actually in Compose everything is a widget, everything is a function. So padding, spacing, center, here is like widget center, what centers its content inside, and you just pass in, for example, to button this. It's bad example. Let me just next one. For example, here we have this text widget, and as you see, we set text from our username. And our user, it's a user object from our view model list of users. Then, if, for example, we'll change the username in this list, it will redraw. It will be recomposed on our UI, and we'll see the changes immediately. So also, as you can see, it's really easy to implement, like ripple effect or a lot more stuff using composes even on pre-alpha stage. And here is the function that put it all together, button and our text, actually username. It just we just call two functions, user row data and remove user button from another user row function, and we can see here this flex row, and actually here is row and flex row. The difference is with this expanded inflexible and flexible functions. Actually, here are only two of them, but yeah. Expanded says that its content will take all the possible, all the free space from its container. Container is flex row. Inflexible says that its content will take as much space as it needs. It's like wrap content and like wrap content and like a match parent. And all the things together. Here we can see our whole list. How does it work? We create vertical scroller. Vertical scroller, it's like just scroll view, and we put in column. Column is like vertical linear layout. So row it's like horizontal linear layout. Column is like vertical linear layout. And we just iterate through our list of users and call the user row function. This is user row function. And we call this function from just in the body of our for each. Looks great, as for me. And by the way, do you see this .dp extension function? I think that we all write it all the time. I mean, for each project, you can be happy. It's like we can use it out of the box right now. Like not big deal, but also good. Okay, then you say, what about navigation? How to do it? If we don't have any fragments, we have only one activity, and we like have to change our screens, our UI, or something. How to do it? What do you think? Any idea? You're right. Okay, let's see. We can create like object nav controller, which with one current screen property, mutable property, and annotate it as model. So it will also observe its changes and updates the UI. And it will update all the UIs that depended on current screen. And if we like depends in the root of our UI on this current screen, it will change our UI. So we see the screens, we have user list and user details, yeah? And the function navigate to, just to simplify everything. Also, we have this root function. It's actually up function. If you remember, we called it from onCreate. And we can see here that we use this crossfade, now controller, current screen. Crossfade, it just says that all UI that will be changed with current screen changes will be done with animation, crossfade animation. So here we just check our screen, and if it's user list, we call user list function. If it's user details, we call user details function and pass user in. So what about styles? It is painful right now, yeah? What about styles? You can see we call here material team function, but actually we can define our own, but I just didn't have enough time to write the whole thing. And we can override like colors, like typography and other stuff, just with our custom implementations. For example, here it's current team colors. It looks like that. It's also model, it's also observable. So if we change this variable in runtime, it will change the theme for our whole application at the same time. For example, we have light theme and dark theme. And we just like on click on the button, do something like that. We check if what's current theme and switch them. It works the same way with typography, and we can change the same way our font family and actually font style, font. So let's summarize everything. What issues do we have? We don't have actually use XML anymore, so we can do like this. And we don't have Vue.java anymore. And we actually write less code, because first we don't have to synchronize our state and our local state. We don't have to write a lot of XMLs, and it really looks smaller. So no boilerplate. Then, as I said, that Composite is like independent library, and you can just include it like any other library, and it can be updated each week, for example. Screen rotation. So currently in pre-alpha it's not solved yet, but Googlers say that they will do it. But we can work around it. We can like just enable manual handling of configuration changes and just recompose our UI after screen rotation. Oops. Inconsistency. So as we don't have XML, we don't have custom views, we don't have local states, we don't have inconsistency. And styling, you just saw, it's really pretty easy, pretty cool, and I really like the way it works now, and I definitely will use it once it beta at least. What about future? Constraint layout. You would say, do we need it? But yes, because if we write some complex UI with composers now, we would have a lot of curly brackets, and our code will move to the right side of our screen, and constraint layout can solve this problem. Recycler view. The list from my app, it's just scroll view with vertical liner layout, and if we have like 1 million of items in, it will be really slow in UI. And the resources. Coroutine support. So I don't really sure I understand how it should work, but I think that it will be like it's now. You can you have like coroutine in UI dispatcher, and it's not blocking thread when you do something, but it's still UI thread. So definitely it will increase performance really well. So small presentation of the app, how it works, and you can see that it works pretty well, and dark theme changes like without any activity recreation or something, and I think you should like it. So resources, I actually haven't included all resources here because I just forgot, but I will share it. I think it will be in Facebook or, yeah. Okay, so composes. Any questions? Yeah? Disadvantages of composes? Yeah, but the main the main idea is not is about that first you write all code in Kotlin only. So in future they can do like you could use absolutely the same code without any changes to build the app for iOS, for example. You know. So you just write everything in Kotlin. It's pure Kotlin. You can include this library even in not Android project, but it will not work right now. But maybe in future. So it's first thing, and let me. Lines of codes. Yeah, disadvantages. Maybe it's like. A lot of functions, a lot of nested functions, and maybe it can confuse a little. But you know, why actually pre-alpha exists right now, and why they make it public? Because we as developers, we need some time to work with it. We need some time to change our minds, because it's actually a little different approach that that we have currently. And to write good code, we need some time. But okay, question wasn't about that. Okay, next one. Okay. Just a second. Okay. For one more. For example, we have this button, and we actually don't have any logic in this function, because we just have this lambda that passes like through all the tree. Maybe it's not the best approach, but it's no, it's not, because your logic is inside your view model. You like just can you can replace this method with your curly fingers and do something curly brackets and do something else here. You can pass actually whatever I want. So how do you actually think it's possible not to pass any like click listener here and how the button, something like that. So actually we can have our like view model and have logic there, but I'm sure it's not like the best approach, and there are a few better architecture patterns for doing this. For example, some MVI or something like that. But it was like easier to do it like this. And what was the second question? Oh, I actually don't know, but I think that only Google knows. Yes, but in other hand, here is Kotlin, and Flutter works with Dart, and like maybe they want to move in this way, moving with Kotlin or something like that. Not sure. And I'm sure that it will also be like cross-platform, and it allows them like support other platforms. Yes. Yeah. Okay. It's a good question. It's a really good question. Mm-hmm. No, it will be about constraint layout. It will not be constraint layout. It will be just like implementation like that. Different technology, yeah. How does it work actually? Like under the hood in Towards, there is like one layout. It's crane wrapper, and it contains only canvas, native canvas, and everything is just drawn on canvas in one layer. No, it's native canvas. Yes, yeah, yeah.
Okay, thank you. Please, we can go on the talk break. Who will try to disagree with me that Vlad's talk was wonderful? I think really it was great, and thank you for your time. And I'm not sure that you tried